This podcast is on concentration calculations. Concentration is the way chemists describe solutions. We need to begin with a few definitions. First of all, the solubility of a solute in a solvent is sometimes limited. And so we have some terms, one of which is saturated solution. That's a solution that contains as much solute as will dissolve at a specific temperature. That's often referred to the solubility of a solute. A solution which is unsaturated has room for more. There is a special kind of solution that sometimes you'll come across. It's called supersaturated. A supersaturated solution contains more dissolved solid than a saturated solution at that temperature, and so it's an unstable situation. What we have here is a video showing a supersaturated solution of sodium acetate. We're going to add a seed crystal to it. The solution begins to precipitate, and a solid forms with the little rays radiating out and eventually becomes a solid mass. Sodium acetate does this. When it does so, it releases heat, and some of you may have seen these or used them as hand warmers. That's a supersaturated solution adding the seed crystal. Solutions are mixtures, and the amounts vary, one of which is concentration. Concentrated. A concentrated solution has a large amount of solute, say 6 or 8 moles per liter, whereas a dilute solution has a relatively small amount of solution, say 0.6 or 0.8 moles per liter. Notice the moles per liter. Here we have two solutions. Solution A, 3 balls in a liter. Solution B, 5 balls in a liter. Solution B is more concentrated than solution A. But you have to be careful in doing this. Just because there's more balls doesn't mean it's more concentrated. If you take a quick look at this, you might think, oh, why is more concentrated than X? But in fact, they both have the same concentration. It's because while there's more balls, there's also more volume. And so we need to make sure we're very careful with our calculations. Mass percent is a way that lots of people have described concentrations of solutions. It's used in the pharmaceutical industry. It's not much used in chemistry. Parts per million, parts per billion. It's used in water quality testing, in contaminant testing, but again, not much use in chemistry. This is the big one, molarity. It's given the symbol M. It's the moles of the solute divided by the liters of the solution. We're going to use this one a lot. And there is the formula for it. Concentration, expressed as molarity, is equal to the moles divided by the volume. You need to know this formula. There's a fourth one called molality. It's a lowercase m. It's moles per kilogram. We will use that one in AP chemistry. Let's look at some examples. This is a rather fishy way of looking at things. But if we have one fish dissolved in 1 liter of water, notice the quick conversion of 1,000 mils to 1 liter, we could say our concentration is 1 fish hour. On the other hand, if I have 2 fish in there, I would call it 2 fish hour, right? If we had another example where there were 4 fish present, it would be, 4 fish hour, okay? And if we had a totally different system, this time we had 20 fish in 5 liters, well, it would also be 4 fish hour, because 20 fish divided by 5 liters also gives you 4. And so concentration is volume independent. It's also total number of moles independent. It's very useful for chemistry. But you know that chemists don't deal in fish. They deal in moles. And so it's the exact same thing. If we have 2 moles, we have 2 molar. If we have 4 moles in a liter, we have 4 molar. If we have 20 moles in 5 liters, we still have 4 molar. And the little wee one up top, I've got a volume of 250 mils. That's 0.25 of a liter. There would be 8 moles inside. 8 divided by 0.25, it is 32 molar. You might notice the square brackets. Those square brackets mean concentration. So, let's look at a real calculation. How many moles of solute are required to make 1.35 liters of a 2.5 molar solution? Well, moles is concentration times volume if you rearrange the expression. So we put in our values, cross out our units, do the arithmetic, 3.38 moles. But moles of what? Depends on what the concentration, what the solution is. Notice that the number of moles is independent of the identity of the material. You have to be careful about this. If, for example, it was a solution of sodium hydroxide, you would take the number of moles and you would multiply that by the molar mass of sodium hydroxide, which is 40 grams per mole, and we will come out with a value of 135 grams. If, on the other hand, we were looking for magnesium phosphate, you would take the 3.38 moles of magnesium phosphate times the molar mass of magnesium phosphate over a mole, and we end up with an answer of 889 grams of magnesium phosphate. So it depends on the identity to make up the solution. What if we go the other way? What's the concentration if we dissolve 58.6 grams of barium hydroxide in 5.65 liters of solution? Now we need to begin with the material. First step, how many moles of barium hydroxide do I have? Well, the moles of barium hydroxide is 58.6 grams of barium hydroxide times 1 mole of barium hydroxide over 171.3 grams. That's the molar mass from your periodic table. It's 0.342 moles of barium hydroxide. Then we need to calculate the molarity. So we have concentration as moles per liter. So we take the values, 0.342 moles divided by 5.65 liters, and we get our final answer of 0.061 molar barium hydroxide. Notice I said molar. That's how we describe moles per liter concentrations. Finally, what if I have 10.8 grams of potassium nitrate? How many milliliters of a 0.14 molar solution can I make? Well, first you need to find the number of moles, right? That's 0.1068. This goes back way to Chem 1. Then, since we know the concentration is number of moles divided by volume, if you multiply both sides by V and divide both sides by C, we arrange to get volume equals number of moles divided by concentration. Substitute in your numbers, do the arithmetic, and then multiply by 1,000 to convert liters to milliliters. We have our final answer of 763 mils. Those are 3 calculations that we do with solutions.